So now we are talking about solving system of inequalities, right? In the last chapter, we talked about solving system of equations, and I remember we talked about solving equations by using what? A graph, where we found the intersection, and we talked about consistent system, independent, we also talked about inconsistencies, and we also talked about solving inequalities, right? No, we didn't do inequalities, just equations, and we talked about how to solve it using what? The substitution method or the addition method. We talked about that before we went on our break. So now we're going to talk about solving inequalities as a system. Not just two equations, but two inequalities, right? So how do you solve it and why? Because I'm now anticipating questions like, why are we ever going to need this? I'll tell you why before we even start, so that way I don't get that question again. Now, assume this, Mr. and Mrs. Calix, right? I didn't use your last name, I don't know why, it just came to my mind, are driving across the country with their two kids, right? And then they plan on driving a max of 10 hours each day. Now, Mr. Calix wants to drive at least 4 hours a day, but not more than 8 hours a day. And Mrs. Calix can drive between 2 and 5 hours per day. Now, the thing is how do you solve this? How do you solve these things? Like, you want to find an ordered pair that satisfies this system, right? Now, if you were to figure that out, how would you do it? You probably can argue with your husband, like, I ain't driving this and you're driving this, I ain't driving this. You know, you can do that, or you cannot say, let's try to find a way to solve this mathematically, right? So this is why this lecture here comes into play.
Do you do that with your wife?
No, I don't.
They pull out the paper and the pencil.
I just drive because I know it's going to solve all problems, right? I'm saying,
and that's the solution.
I'm saying couples that don't know how to discuss things, for you can solve it mathematically, but I know how to say, I'll drive because I'm a gentleman, so I'll do it. Yes, sir.
Hear that, guys?
So they want to drive 10 hours?
Well, they want to drive 10 hours,
Can't
right?
they just
Not more than 10 hours a day.
hours?
So, excuse me?
Can't they both just drive 5 hours?
They can
Yeah,
do that.
that
There's-
seems easy.
There's different options, but the thing is this, you can solve this using inequalities. That's the point. My point is this. Wait, my point is this. Somebody may say, well, I don't want to do 5 and 5. I don't want to do this. So what could work for both of us? Because he says,
Drive, and when you get tired, you
Mr.
switch.
Calix says that I want to drive at least 4 hours a day, but not more than 8, right? But she says what? She wants to do between 2 and 5, right? So then we can solve this system. This is how you solve system of inequalities, right? Now, first of all, the definition, right? I gave you the reasons why we use this. Now we're going to talk about the definition. So what is the definition? What is the system of inequalities? It means finding an ordered pair that satisfies the conditions, right? Solving this is meaning finding an ordered pair that will solve or that will satisfy the conditions. We can find an ordered pair that will satisfy this condition, which means, okay, Mr. College, you can do 6, your wife can do 4. Mr. College, you can do 7, your wife can do 3. Or, because she doesn't want to do more than 2 and 5, right? So she's in this interval here. So there's different options. You can tell her, honey, I'm tired today. You can do 3, I'll do 7. Or you can do both 5 and 5, right? If you really want to be like 50-50, because women say 50-50, right? Or you can say, all right, I'm going to be nice. I'll do 8, and then you do 2, right? Okay, so you get my point. There's different options, right? You can have an ordered pair that will satisfy this because there's several options here, right? And we use this system of inequalities to do that. So that's basically, you guys are talking, and then while you're talking, I'm sitting there computing this in my head and thinking, all right, I can use my mathematics knowledge to do this, right? All right, so now, the first example is this. We're going to talk about solving intersecting regions, solving a system that gives us intersecting regions, right? Intersecting regions. So how do I solve this here? I have 2 inequalities, right? The first one says what? Y is greater than what? 2x minus 4. And the second one says y is less than or equal to what? Negative 0.5x plus 3. And I want to solve this. So how do I solve this? I'm going to graph it and figure out the solution, right? Remember, before we left, we learned how to graph what? Inequalities, but it was just one inequality. Now you have 2 of them. It's not just one, you have 2 inequalities that you have to put on a set of axes, right? So now let's go ahead and let's do that. So let me draw my set of axes, right? So my first equation is y is more than 2x minus 4. I already know that my solution is going to be what? It's a dotted line or a solid line here? Dotted line, right? So my y-intercept is what? -4. So I'm going to start with -4. 1, 2, 3, 4. And I'm going to go up how many units? 2 and over to the right? 1. So 1, 2, 1 right here, right? So I'm going to have my dot. And then I'm going to have this here, right? So now I need to figure out which region is the solution. But before I get there, I also need to graph this guy here. Okay? So that's what we're going to do. We're going to now graph this now. -0.5, because this is a decimal number, I can turn this into a what? Fraction. Thank you very much, Nick. So this is going to be -1/2x plus 3, right? That's what I have. Now what's my y-intercept? 3, right? So I'm going to go 1, 2, 3, and I'm going to go down what? Down 1, and then over 2, right? 1, 2, right? Down 1 over 2, so then I'm going to draw, this is a solid line. Now I need to figure out what my solution is, right? I have two systems of equations. So again, remember what we said, we always use what? 0 and 0, right? And double check this statement. So I'm going to start with my first line here. So I have 0 is less than 2 times 0 minus 4. 0 is more than -4. True or false?
Yes.
True, right? This is true. And then 0, 0 is here, right? So because this is true, am I going to shade here? Or am I going to shade this side?
You're going to shade the side with 0, 0.
Right. I'm going to shade the 0, 0 side. So I'm going to go bing, 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 bing.
You shade the side that's true, right?
Yeah, the true side is what you shade, right? For the first line. Now for the second line, I'm going to do the same thing, right? I'm going to replace this by 0 and this by 0. I get 0 is less than or equal to 3. True or false?
True.
True, right? So therefore, I'm going to use the pink pen, the pink marker now. So this is 0, 0 again, right? I'm going to go boom, 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 right? So now the solution is where they both intersect. Let me say that again. The solution is where they both do what? Intersect. So where do they intersect? Is he here? Is he here?
No.
Where is it? Right here, because the cross, right? You see that's where they intersect. Why y'all laughing? So this is the solution. The solution is right here.
Oh, is it where the shaded?
Yeah.
intersects? Oh.
Where they both shaded, right? They're both here. I have a green, I have a pink here. So that's my solution.
So do you circle it?
I circle that, right? I put solution and I put the big, yeah, circle and put solution, right? So that's my solution. This is where I want to be. Because that's where both regions intersect, right? Let me say that again, regions. It's not just two lines are intersecting, but regions, right? This region and this region. So my intersection is right here. So that's where they intersect. And this is going to be my solution. Does that make sense? Are we good on that?
Yeah.
All right. Okay. So these are called intersecting regions. The regions are what? Overlapping, right? This is where they meet. So that's the intersecting region. Now, the next thing we're gonna do is we're gonna also have another example where now we have what you call separate regions. Yeah. All right. All right. So now we have like separate regions here, right? Separate regions. So we're gonna see a case where we have separate regions. See how that looks like. So now I'm gonna erase this. Again, the same process. I have my set of axes. Now here, this is y is more than or equal to 1x plus 5, right? So 1 over 1. So that's my slope is 1 over 1. So if I'm at 5 here, right? 1, 2, 3, 4, 5. I'm gonna go up 1 and over to the right 1, right? Again, this time is gonna be a solid line. That's my first graph, right? Solid line. Again, I don't worry about like drawing my solution yet. I need to wait. And then the next graph is x minus 4. The slope is the same again, 1 over 1. So I'm going to start at -4. 1, 2, 3, 4. I'm going to go up 1, over to the right 1. So right here. What do you already notice here?
Parallel.
They're a parallel line, right? Something is going to happen. But I need to double check this. I'm going to replace this by 0 and this by 0, right? So if I do that, I get 0 is more than or equal to 5. True or false?
False.
False, right? So 0, 0 is here. So what's my solution? Here or here?
Out, out.
Up, out, right here, right? Now watch this. And now here, 0 is less than -4. True or false?
False.
False, right? 0, 0 is here. So am I shading here or out here?
Outside.
Outside. Now what do you think the solution to this system is?
Zero.
No solution because there's no intersection, right? This guy is way here, the wife that complains a lot, and this guy's here, the husband that say, I'm not going to talk today, I'm going to be quiet, right? So therefore, there's no intersection. They're not overlapping. So therefore, there is no, right, solution,
Hey, we need a real world example.
right? That's a real world example. Very easy, right? She's out here. He goes, you know what? I'm not gonna talk. I'm just gonna be a baby man. And she no solution, right? No solution because they don't overlap. Now here we have a solution. I can use a real world example. The wife is talking, and he goes, you know what? For the sake of just being like a gentleman, I'm gonna abide by your law. So he'll be called that kind of man what? A sucker. Because he's like, yes, ma'am. You know, like
Where did you get this example?
Just let me do
Well,
it.